Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss probability. In this chapter, we are going to discuss the problems in the exercise 15.1, page number 283 in the textbook. Okay, my dear children. In the previous class, we have discussed the concepts of this exercise. I hope you have understood the concepts of this exercise. I hope you have learnt the concepts well. Haven't you, my dear children? Right. Now come to the problems in the exercise 15.1. See the question number 1. First question in the exercise. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. Understood this question, my children? A batswoman is there. She hits 6 times. Out of 30 balls she plays. She played 30 balls. Out of 30 balls, she hit 6 times a boundary. Understood this point, my children? Now we have to find the probability that she did not hit a boundary. Understood this point, my children? Right. Now let us consider this event. E be the event of, let E be the event of, let E be the event of hitting a boundary. Hitting a boundary. Okay, my children, just we are assuming that E be the event of hitting a boundary. How many times she hits the boundary? 6 times. Yes or no, my children? So, number of times she hits the boundary. She hits the boundary 6 times. Okay, my children. How many balls she played? 30 balls. Okay, my children, understood this one. She played 30 balls. So, number of balls or total number of balls? Total number of balls. Total number of balls she played. How many balls she played here? 30 balls she played. So let us find the probability of this event E. Okay, my children. Therefore, P of E. This notation denotes the probability of the event E happening of the event E. So how can you find number of times she hits a boundary whole divided by total number of balls she played. Okay, my children. Number of times she hits a boundary whole divided by total number of balls she played. To find the probability of this event, this is the formula. Okay, my children. So what is the number of times she hits a boundary? 6 by total number of balls she played? 30. Understood this statement, children? Right. 6 1 times, 6 5 times. That is equal to 1 by 5. This is probability of E. Means the probability of event of hitting a boundary. Okay, but children. But in the question, what is asked here? The probability of that she did not hit a boundary. Okay, my children. Right. Therefore, probability of not hitting a boundary is equal to 1 minus P of E. 1 minus P of E means P of 1 minus probability of hitting a boundary. Okay, my children. Right. That is equal to 1 minus 1 by 5. Okay, my children. Understood this step? By taking LCM, what will get? 5 minus 1. What will get here? 4 by 5. This is the required probability. Understood this question, my children? Right. Now come to the question number 2. Second question. 1500 families with 2 children were selected randomly and the following data were recorded. Okay, my children. Here 15 families were selected with 2 children. In every family 2 children are there. So such families are 1500 families are there. We have selected by chance. Randomly means choosing by chance. Then we have recorded the data. See here, my children. Out of 1500 families, 475 families have 2 girl child. Out of 1500 families, 814 families have 1 girl and 1 boy. Out of the 2 children, 1 girl. Okay, my children. The other child is a boy. Understood this point, my children? Similarly, out of these 1500 families, 211 families do not have any girl. Means the 2 children are boys. In these 211 families, the 2 children are boys. No girl is there. Understood this point, my children? Understood this data? Now compute the probability of a family chosen at random having 2 girls, 1 girl and no girl. For these 3 events, we have to find the probability separately. Understood this point, my children? Right. Now, let us find the total number of families. Okay, my children, come to the solution. Total number of families. Add all these 3. Automatically we get to 1500. Yes or no, my children? 475 plus 814 plus 211. By adding these 3 numbers, we get to 1500. Total 1500 families were chosen. Okay, my children? Right. Now, what is the first question? 2 girls. So, the probability of a family having 2 girls. How many families are having 2 girls? 475. Yes or no, my children? So, number of families having 2 girls whole divided by total number of families. Here I will write in the next step. Here clearly. Here I will write in the next step. That is equal to, here I am writing the same step here. Number of families having 2 girls whole divided by total number of families. Understood this step, my children? Right. How many families are having 2 girls 475. Yes or no, my children? 475 by what is the total number of families? 1500. Yes or no, my children? 1500. Now let us simplify by 5 table. Let us divide the numerator and the denominator by 5 table. 5 300 times, 5 9 times, and 5 times. Again divide the numerator and denominator by 5. 5 6 times, 0. Here 5 1 time, 5 9 times. That is equal to 19 by 60. This is the required probability of a family having 2 girls. Understood, my children? Right. Now the second part of this question is we have to find the probability of a family having 1 girl child. Yes or no, my children? So probability of a family chosen at random having 1 girl. Okay, my children. Now we are going to find the probability of a family chosen at random having 1 girl is equal to, how do you find the probability? Number of families having 1 girl whole divided by total number of families. Okay, my children, understood this step? Right. That is equal to how many families having one girl? 814. So 814 whole divided by what is the total number of families? 1500. Yes or no, my children? 1500. Now let us simplify this fraction. Let us take the 2 table. Divide the numerator and denominator by 2 table. 2 4 times, 2 zeros, 2 7 times, 2 750 times. Okay, my children. So hereafter we can't simplify these two numbers. So 407 by 750. This is the required probability of a family chosen at random having 1 girl. Understood this point, my children? Right. Now come to the third part. Probability of a family chosen at random having no girl is equal to, how do you find the probability of a family chosen at random having no girl? How many families are not having even a single girl? 211. In these 211 families, the 2 children are boys. No girl is there. Okay, my children, understood this point? So, number of families having no girl whole divided by total number of families. Understood this step, my children? Right. So 211 by 1500. Okay, my children, we got the probability of the third event also. Okay, my children, understood? Right. Now come to the question number 3. Page number 247. This question was given in the page number 247. In a particular section of class 9, 40 students were asked about the months of their birth, and the following graph was prepared for the data so obtained. Okay, my children, here this is a graph of a data which represents the months of the students in a class 9th. Okay, my children, which has 40 students. So this is a data, pictorial representation of the data. Okay, my children, in the January 3 students were born. In February 4 students were born. March 2, April 2, May 5, June 1, July 2 students, August 6 students, September 3 students, October 4 students, November 4 students, and December also 4 students. Okay, my children, understood this graph? Right. Now we have to find the probability that a student of the class was born in August. How many students were born in the month of August? 6. Okay, my children, understood this question? Right. Now let us find the probability. Total number of students. How many students are there? 9, 20, 40. Total number of students in the class. Total number of students in the class by adding all these numbers we get 40. Total number of students 40. Okay, my children. Right. How many students were born in the month of August? Yes, 6 students. So, no, my children. So, number of students. Number of students of the class was born in the month of August. In the month of August. How many students were born? 6. Yes or no, my children? Right. Understood this step, my children? Right. Therefore, probability that a student of the class was born in the month of August is equal to number of students born in August whole divided by total number of students in the class. Okay, my children, understood this step? So, how many students were born in the month of August? 6 by total number of students in the class 40. Understood this step, my children? Right. 2 3 times 2 20 times. That is equal to 3 by 20. which is the required probability. Understood, my children? Right. Now come to the question number 4. Fourth question. Three coins are tossed simultaneously 200 times with the following frequencies of different outcomes. Observe this table, my dear children. Here 200 times. Three coins are tossed 200 times. Okay, my children. Out of these 200 times, 23 times 23 times we got 3 heads up. Okay, my children, understood this point. 72 times 2 heads up. On the third coin, head. Tail. On the third coin, we got a tail up. Understood this point, my children. Similarly, 77 times coins, one coin showing head up and the remaining two coins showing tail up. Understood this point, my children? Next, 28 times out of 200 times, 28 times showing all the three coins tail, no head. Understood these points, my children? Right. If the three coins are simultaneously tossed again, compute the probability of two heads coming up. Understood this question, my children? Right. So, how many times three coins are tossed? 200 times. Total number of times three coins are tossed simultaneously. That is equal to 200. Understood this step, my children? Right. Now, come to the event. For which event you have to find the probability of two heads come up. How many times we are getting two heads up? 72 times. Yes or no, my children? Right. Number of times three coins shows two heads up. Two heads coming up. How many times? 72 times. Understood this step, my children? Right. You got this number and this number. These two numbers are enough to find the probability of two heads come up. Therefore, probability of two heads come up is equal to number of times three coins show two heads come up whole divided by total number of times three coins are tossed. Understood this step, my children? Right. That is equal to how many times three coins show two heads come up? 72 by total number of times three coins are tossed. How many times? 200. Understood this step, my children? Right. 8 table. 8 9 times. 8 25 times. That is equal to 9 by 25. I divided the numerator as well as the denominator by 8. Then 8 nines 8 25 times. So 9 by 25, which is the required probability. Understood, my children? Right. Now come to the question number 5. Fifth question. An organization selected 2,400 families at random and surveyed them to determine a relationship between income level and the number of vehicles in a family. Okay, my children. The information gathered is listed in the table below. So observe this table, my children. Here in this column, monthly income in rupees. Here vehicles per family. Number of families having zero vehicles. No vehicles are there. Number of families having only one vehicle. Here number of families having two vehicles. Number of families having about above two vehicles. Okay, my children, understood this point. Less than 7,000 rupees. Income is less than 7,000 rupees. So, zero vehicle families, 10 vehicles, 10 families are there. Only one vehicle, 160 families are there. Only two vehicles, 25 families are there. And above two vehicles, no families are there. Okay, my children. From the families having the income 7,000 to 10,000, zero vehicles, zero families are there. One vehicle, 305 vehicle families are there. Two vehicles, 27 families having two vehicles. Two families having about two vehicles. Understood this table, my children? The families having the income 10,000 to 13,000. One family does not have any vehicle. 535 families have only one vehicle. 29 families have exactly two vehicles. And one family have exactly above two vehicles. Okay, my children. Similarly, the families having the income 13,000 to 16,000. Two families have no vehicle. 469 families have only one vehicle. 59 families have exactly two vehicles. 25 families have above two vehicles. And similarly 16,000 rupees and or above. The families whose income is 16,000 or above, only one family does not have any vehicle. 579 families, exactly 579 families have only one vehicle. 82 families have two vehicles. Okay, my children. 88 families have above two vehicles. Understood this table, my children? Right. Suppose a family is chosen. Find the probability that the family chosen is first one earning 10,000 rupees to 13,000 per month and owning exactly two vehicles. We have to find the probability of this event. And second event, earning 16,000 rupees or above per month and owning exactly one vehicle. We have to find the probability of this event. And the third one, earning less than 7,000 rupees per month and does not own any vehicle. This is the third event. We have to find the probability of this third event. Similarly, fourth one, earning 13,000 rupees to 16,000 rupees per month and owning more than two vehicles. Okay, my children. For this event, we have to find the probability. And the last one, owning not more than one vehicle. These are the five events. For all these five events, we have to find the probability. Understood, my children? Right. Now, come to the solution part. What is the total number of families here? 2,400. Yes or no, my children? Total number of families 2,400. Okay, my children, this is the total number of families. Now, first question, first part. How many families are earning 10,000 rupees to 13,000 per month and owning exactly two vehicles? Please observe the table, my children. How many families are having two vehicles earning 10,000 rupees to 13,000 rupees per month? Yes, 29. Okay, my children. So, number of families earning 10,000 rupees to 13,000 rupees per month and owning exactly two vehicles, that is equal to 29. By observing the table, we got here 29. Understood this statement, children? Therefore, probability of a family chosen at random earning 10,000 rupees to 13,000 rupees per month and owning exactly two vehicles. Understood this step, children? Is equal to 29 by 2,400. Yes or no, my children? I am not writing this full sentence here. Okay, my children? This number by this number, 29 by 2,400. Understood this step, my children? Right. Now come to the second part of the question, my children. Number of families earning 16,000 rupees or above per month and owning exactly one vehicle. How many families are there? Please observe the table, my children. How many families are there? 579. Yes or no, my children? 579 families are there earning 16,000 rupees or above per month and owning exactly one vehicle. Okay, my children. Therefore, probability that the family chosen is earning 16,000 rupees or above per month and owning exactly one vehicle is equal to this number by total number of families. Okay, my children. So 579 by 2,400. Okay, my children, three table. Let us strike out the numerator and the denominator by three table. Three ones, yes or no, my children? Three nines and three times. 800 times. That is equal to 193 by 800. Okay, my children, understood this part? This is the required probability. Okay, my children. Right. Now come to the third part. Number of families earning less than 7,000 rupees per month and does not own any vehicle. Please observe the table, my dear children. How many families are there? How many families are there? They earn 7,000 rupees, less than 7,000 rupees per month and does not own any vehicle. Yes, 10 families, only 10 families are there. Okay, my children. Therefore, probability that the family chosen is earning less than 7,000 rupees per month and does not own any vehicle is equal to this number by total number of families, that is equal to 2,400. Okay, my children. By dividing the numerator and denominator by 10 table, 1 by 240. This is the required probability, 1 by 240. Understood this step, my children? Right. Now come to the fourth part. Number of families earning 13,000 rupees to 16,000 rupees per month and owning more than two vehicles. Observe the table, my children. How many families are earning 13,000 to 16,000 rupees per month and owning exactly more than two vehicles? Observe the table, my children. Yes, only 25. 25 families are there. As of now, my children. So 25 families are there. They are earning 13,000 rupees to 16,000 rupees per month and owning more than two vehicles. Okay, my children. Therefore, probability that the family chosen is earning 13,000 rupees to 16,000 rupees per month and owning more than two vehicles is equal to this number by total number of families. Okay, my children. So 25 by what is the total number of families? 2,400. Okay, my children. Understood this step. So 25 one times, 25 96 times, that is equal to 1 by 96. This is the required probability. Understood, my children? Right. Now come to the last part of this question, my children. Number of families owning not more than one vehicle. We have to find first number of families owning not more than one vehicle. We can find this number by adding these two numbers. What are the two numbers? Number of families owning zero vehicle plus number of families owning exactly one vehicle. Okay, my children. Right. Observe the table, my children. How many families are owning zero vehicle? Yes. 10 plus 0. 10 families are owning zero vehicle. In that column, see the column. 10 plus 0 plus 1 plus 2 plus 1. All these families do not have any vehicle. Okay, my children. Now let us find the number of families owning exactly one vehicle. How many families are having exactly one vehicle? 160. Observe the table, my children. 160, 160, 305 plus 535, 535, 400, 469, 469 plus 469 plus 579. All these families, this number of families owning exactly one vehicle. Okay, my children. Now let us simplify these numbers. Then what will you get here? 10 plus 1, 11 plus 2, 13 plus 1, 14. Okay, my children. Now let us add. Let us add all these five numbers. What will you get here? 2048. Okay, my children. Now again let us add these two numbers. What will you get? 2062. Okay, my children, understood this step. Therefore, probability probability that the family chosen owns owns not more than one vehicle, not more than one vehicle is equal to this number by 2400. Total number of families 2061 by 2062 by 2400. Okay, my children, let us strike out. Let us divide the numerator and divide denominator by the table 2. Then what you get? 2 10 times, 2 3 times, and 2 1 times by 2 1200 times, which is the required probability 1031 by 1200. Okay, my children, understood? Right. Please try the remaining questions in this exercise, my dear children. Try yourself. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my dear children. Right.